Questions? Okay. All right. Want to do some more? I mean, we're gonna anyway, so. All right, so this chapter is all about making connections between, the equation of some relation between two variables and its behavior in the plane. We're going to start. Some of this will be review. I mean, you've all done stuff with here's the equation of a line. So this is a pretty short section. It's just a couple of pages. We're going to refresh our memories. And then as time allows, we'll talk a little bit about the circle in the next section. So here's the slope-intercept form of a line. It's the one we usually all know and love really well. Mx plus b, where m is the slope and b is the y-coordinate of the y-intercept. It can be convenient to use if we're graphing the line because you get a point for free. Like mx plus b, you get that y-intercept for free, and then you can use the slope to get another point. And we all know you only need 2 points to make a line, and so it ends up being kind of convenient there. If I want to sketch a graph of this line, by the way, that's called the general form, where just everything's sort of collected on one side and it's set equal to 0. But the first thing I would do is just put it in slope-intercept form. So if I throw everything but the y's on the other side, and then divide by 2. We get negative 2x plus 3. So the y-intercept is the point 0, 3. So there's a point for free. How do I get another one? We could, yeah. So there's more than one way, right? So I was thinking about just using the slope, right? Because it's got a slope of -2, and I'll just go down 2 over 1. But yeah, absolutely, you could plug in the value for x as long as it's not 0, because we're already using that one. If I plug in 1 for x, then we get negative 2 plus 3 is positive 1. So you could plug in another value, or you could use the slope. In fact, if I used the slope once, that's precisely the point that we get, because we go down 2 over 1. And then we connect the dots. So that's the slope-intercept form. The point-slope form of an equation looks like this. And I find it really convenient to use this if I were given some information and asked to find the equation itself. Because if I know the slope and I know any point that's on the line, then I have enough information to fill in this equation. This really comes from just the slope formula, right? So the slope formula is y2 minus y1 over x2 minus x1. And if I were to multiply both sides by x2 minus x1, you will get this equation, except they've replaced the x2, y2 with just x and y. The distinction here is, of course, anything with a subscript, the x1, y1, those would be the coordinates we know, but plain old x and plain old y are variables, right? They're going to stay at just plain old x and plain old y. Let's find the equation of a line that passes through these two given points. They gave me 2 points, so certainly I can find the slope. So let's start there. So we get, 2 plus 1 on top, 6 minus 2 on the bottom, so that's 3/4. We now have everything we need to find the equation of this line. I'm going to start by writing out the point-slope form. So y minus y1 is equal to m times x minus x1. Now, it really doesn't matter which of these points you pick. I mean, we know, we can use the point-slope form if I know the slope and I know a point. And we do. We've got 2 points. Just make sure, just pick one. It really doesn't matter which one you pick. I mean, if I wanted to be consistent with my subscripts and how I label them, then I can pick this one. But you'll still get an equation that represents a line if you pick the other one. So y minus, I'll use this point, y minus, no, that would be plus 1. Is equal to 3/4 x minus 2. Now, if you're asked to find the equation of a line, if I ask you to find the equation of a line, and I don't specify what form it should be in, point-slope form is fine. So you can be like, okay, I'm done, there it is. Sometimes a question will specify that it wants it in slope-intercept form, and if you want to get it in slope-intercept form, you just solve for y. So we could distribute that 3/4 minus 3/2, and then subtract 1. So either of these is fine. When you're working on exercises, they may or may not specify, but when you go check your answer in the back, maybe they've chosen one form over another, so you just might need to change your form to see if your answer agrees with what they have. Questions? Okay. Couple of facts. Vertical line has a fixed x coordinate. That's what makes it vertical, right? The x that never changes. So that has an equation, x equals some number. And a horizontal line, every point on a horizontal line has the same y coordinate. That's what makes it horizontal. So the equation of a horizontal line looks like y equals some number. Now the general form, I already alluded to this before, but the general form is when we've got all the terms collected on one side. So it's set equal to 0. And usually, unless there are some irrational coefficients, we try to make sure that a, b, and c are integers, so we clear any denominators. We want to find the general form of the equation of a line passing through the point -1, 2, and then parallel to this line they give us. Now they ask us, note, they ask us for the general form. I'm going to take that request, I'm going to set it aside till the end. I'm never going to start by trying to find the general form. What I'm going to do is just find the form of the equation, and then I'll use algebra to get it into the general form. There's nothing particularly useful about that general form. I mean, depending if you're solving some systems of equations, like it can be useful there. But when it comes to like using this information to come up with an equation, I almost never start with general. So it passes through this given point, and it's parallel to the line. Now, I either need 2 points or I need a point and a slope. They've given me a point.
And then they give you the inverse or the slope.
Right. So, and what tells you that?
Well, parallel.
Parallel, right? So it's parallel to this line. So if I can find the slope of this line, then my line is going to have the same slope. So how do I get the slope of this line?
Well, you find that you set y, get y equals,
right.
And you plug in the points to the equation.
Yeah, so if I just get y equals, in fact, if I solve it for y, I don't even need any points. Because if I solve it for y, hopefully that means I'll have it in mx plus b, that slope-intercept form, and that slope will be just ripe for the picking. So I'll subtract 3x and add 6 to both sides. And then divide by 2. So we get y equals -3/2 x plus 6. So what does that tell us?
Plus 3, right?
Oh yeah, thank you.
7 -3/2 is this.
Yep. Okay, we've got a point because they gave it to us. We just found our slope. So now I'm going to go to slope, point slope form. So this is an equation that does represent the line they asked us to find. We're just not done yet because they asked us to get it in general form. Now with general form, we want to clear fractions. We don't want any fractions in there. So I usually take care of that first if I have fractions. And that's simple to do here. If I simply multiply through both sides by 2, like there's only one fraction to worry about, right? So like it's easy for me to tell here. I'm just going to multiply both sides by 2 and get rid of the fractions, and then I can gather everything on one side. So 2y minus 4. And then let's see, I'm going to distribute the negative 3. So minus 3x minus 3. I'll add 3x and 3 to both sides. And I get 3x plus 2y minus 1 equals 0. Now, if you took that equation and you multiplied both sides by negative 1, what would happen? What would we get?
What's your question?
If I took this equation that we just found and I multiply each side by negative 1, what's the result? No, like take this equation, multiply through by negative 1, both sides.
The other way.
Say that again? Yeah, so just say it. What is it? What do I write down? Yeah, okay. So now, let's look at what they tell us about the general form for the equation of a line is. Ax plus by plus c equals 0, where a, b, and c are integers. Is that true for both of these lines? Not a trick question. Yes, it's true for both of these lines. So I'm just pointing this out to let you know that maybe when you saw the line, you might get one of these and you look in the back of the book and all the signs are flipped around. It doesn't mean that you made a mistake. It just means that maybe they got all their terms on the other side or something. Usually I think they default to having a positive x coefficient, but there's not a reason that has to be the case. Questions?